So our next speaker today is Stefan Schumacher. Hi, Stefan. He'll be discussing issues of intelligence, probably alternative intelligence of intrusion detection systems, and how this has to do with the reliability of IDSs.
Yeah, so I welcome you to my talk. The topic is the developmental psychology of intrusion detection systems. And first I would like to introduce myself. I'm currently studying educational science and psychology at the University of Magdeburg in Germany. Some years ago I once studied computer science and electrical engineering but quit it. And in 2004 I wrote a short article about intrusion detection systems, and I'm still interested in that stuff. Nowadays I'm focusing on social engineering, security awareness, and I do some research on organizational security, so I may have a different point of view on security than a computer scientist or a hacker. So this is more or less a scientific talk, so I will give no answers but raise more questions. What is the background of that talk? The topics of psychology and intrusion detection systems sounds a little bit strange, but it works well if you think that every intrusion or security incident has a social dimension. To detect or prevent security incidents, the social dimension has to be analyzed. You cannot get along only with a technology-only model. Preventing security incidents means you have to anticipate future events. That means you have to predict the behavior at a future point in time. So from the behavior of someone at the point of time sorry, my tongue. You have to try to predict the future behavior of someone from the behavior he's currently showing. This is called a probabilistic decision in psychology and philosophy, which means that this decision is not very stable, or has not to be very stable or very safe. It is always with some kind of insecurity. To make such a decision, you need diagnostic and prognostic competences and social intelligence. In philosophy, you would call this cognitive faculty or gnosis, which is the Greek term for that. These competencies are the core competencies of psychology and especially psychiatry. So I thought it might be interesting to show the psychologist's point of view onto that topic. There are currently some interesting research projects going on beyond computer science. There was a large school shooting in March in Germany, and a 16-year-old boy killed, I guess, 12 people. And now there is a project going on at the University of Berlin that wants to prevent school shootings and identify potential school shooters. And that can be considered to be some kind of intrusion detection too. The interesting discussion about that project was that the police and some politicians tried to turn schools into prisons with fences and such, and most of the teachers said that doesn't work. We have to use more psychologists and psychiatrists and try to prevent or try to analyze the behavior of students. There is another project going on about analyzing surveillance cameras or the data from surveillance cameras to identify potential terrorists. The idea behind that is that a computer program is being developed that is analyzing the pictures and try to analyze the behavior of human beings. And based on that, it will give a decision if someone is a terrorist or maybe a robber or something like that. There's also, of course, research being done for several years in criminal prognosis and criminology, which is also part of psychology and psychiatry. Or from a philosophical point of view, you have to think about decisions and decision making. Heinz von Förster, who is from Austria originally, made a so-called metaphysical postulate. He said there are two kinds of decisions that can be made: those who already have been made and those who cannot be made. The first kind of decision is or are decisions usually made in nature science, like physics, biology, or such. For example, is the Earth the center of the universe? This is a decision that has not to be made by mankind. We just have to discover if the Earth or the Sun is the center of our universe. So at one point in time, the geocentric model was considered to be the one and only model of universe, but after some time it was overwritten by the heliocentrical model. And this is usually the core of the scientific philosophy of natural science. The second kind of decision, those who cannot be made, are decisions like, should gay marriage be allowed? This is something you can debate of, but you cannot say that decision is true and that decision is false. It is something you will never come to, or you can only come to a conclusion, but you can never find a natural cause for that conclusion. So with regards to intrusion detection or computer science, the verification of a computer program, the theoretical mathematical verification of a computer program is a decision that already has been made. So either the computer program is free of errors or it has some errors. And for example, if you check for buffer overflows, or the check for buffer overflows can be automated because you can write a program that checks a computer program for such kind of errors. The second kind of decision applies to human behavior. For example, if the current behavior mistakes is showing just friendly, or is he trying social engineering? So is he trying to attack me, or is he just a nice person that holds the door open for me? And this one cannot be automated. The second decision cannot be made by a computer because a computer is not able to do a debate. A computer is a deterministic automaton and is only able to conduct those kind of decision. So now I would like to switch over to the developmental psychology. The developmental psychology was mainly influenced by a Swiss biologist called Jean Piaget. He was born in 1896 and died in 1980. And his main research topic was how humans generate cognition. So he analyzed children, especially his own 3 daughters, and he analyzed the development of children. And he created a theory that is called genetic epistemology, and which influenced not only psychology, but also philosophy, social science, and a lot of other fields of science. He described the developmental steps of children, and he described the development of the mind of children. So how are people developing social intelligence? When are people or human beings able to interpret social behavior? So my idea is now to use the genetic epistemology to create a theory of intrusion detection that offers diagnostic and prognostic competences, social intelligence, and cognitive faculty. The genetic concept was introduced mainly by Darwin. He introduced the concept of development as evolution or epigenetics, as it's called in biology. Any kind of evolution is a process that builds new structures and attributes from indifferent genes, so new capabilities are developed. Evolution has no determinable beginning and no defined end. In psychology, we do research on the field of ontogenesis, which means the evolution of one human being, so from birth or gestation to the death of one man, but we also do phylogenesis, which means the evolution of one phylum or phylum. That means the whole mankind. So how did the mankind develop from 2000 before Christ up to now? And this model of phylogenesis could also be used to describe the evolution of science. For example, we could say the scientific progress is some kind of evolution that started with maybe Ptolemy in Old Greek and now went over from Einstein to Max Planck and so on. The main or the central theoretical concept of the genetic epistemology of Piaget is the structure. The structure is the nucleus of development, and it predetermines the direction of any development. The structure has been inspired by the biological concept of holism. Holism means that wait. Oh, okay. There's another slide about holism. That idea of holism led to the genetic psychology and the cybernetic theory of equilibration, which I will describe in another slide. Structures are used to describe cognition via general forms. So Piaget was not interested in describing a specific cognition, but he was interested in describing how cognition is made or how cognition works and how people or maybe even machines are able to generate some cognition competences. And those structures are used to describe how cognition is organized. Piaget, as a biologist, viewed the human mind as some kind of organism which is differentiated from the environment. So the organism of the human mind lives in an environment, but it is differentiated from it, but it also interacts with it. So the human mind does not exist in some kind of vacuum, but it exists in an interaction with other people, with the world, and so on. Structures are, in a general definition, systems of interrelations between the elements and between the elements and the whole. So we have interactions within our mind, and our mind interacts with the world and the environment. Structures are non-static. That means they are able to develop, and they are self-organizing. So actually, we do not organize our structures, but the structures organize us. So our mind is created or organized by the structures itself. This led to the conclusion that the whole is more than the sum of its parts. So cognition is more than just the sum of single perceptions. The cognition of a human mind is more than things I'm seeing or things I'm hearing. A structure can be used on thinking and words, so I can use a structure to describe how thinking works, and I can use a structure on how to describe something in a world works. For example, we can build a structure of the DeepSec conference. It works on mind and matter, so therefore we can also describe the interaction between cognition and reality. Each structure is just a momentum of an uncompleted and uncompletable process of construction. So we cannot say that a human mind or a structure at one point in time is ready and there will be no further development. There will always be further development for any structure that is available. He was then asking or wondering how structures are created or updated. The basic structures are created by hardware, for example, the brain. Each newborn child has functions its brain is capable to do, and for an IDS or computer, it would be, for example, the CPU. A digital alpha has another structure than an Intel Pentium or another computer, CPU. Structures are used to assimilate objects, but objects can also accommodate structures. So assimilation is a function where subjective structures are used on objects which are assimilated into the structures. So whenever I approach a new object, I have to, or my structures assimilate that object into so. So when I first see a new fruit, for example, a banana, I have to find out what it is, how I have to eat it, how it tastes, and so on. But each assimilation is mutually dependent to accommodation. Accommodation is the vice versa process where the object influences the structure. So when I'm first seeing something new, this new object is also influencing the structures or my mental representation of the world. Each action a human being is doing invokes assimilation and accommodation, so we cannot live without that. And whenever we are doing something, these processes are going on. And perception is usually organized, or perception is organizing external events with existing perception structures. So for example, if you're colorblind, you cannot see red and green letters, or you cannot determine if a traffic light is currently flashing green or red. So your mental representation of the world or of the reality is influenced strictly by those structures available by your brain. These are some pictures I used for human development. For example, the first structure any human being has to develop is the structure of crawling or scrabbling, and once you are able to crawl, you can start walking upright. And when you are able to walk upright, you can then start to, for example, ride a bike, and then maybe you can take lessons in ballet dancing. But you cannot strictly go direct, or you cannot go directly from crawling to ballet dancing because the structure of walking upright is not yet developed. So this is some example for a development process. Another interesting point is, especially for psychologists and teachers, about learning motivation. Why are people interested in learning, or why should people learn? Piaget has no explicit motivational theory, but he says that the structures should be kept equilibrated. So he says equilibrated structures are failure resistant. There is no failure possible within these structures. And non-equilibrated structures cause a cognitive conflict within the mind of a human being. He did not describe why or how this conflict happens, but he just said that it happens. And once it happens, any human being is interested in bringing the structures back into an equilibrated point. That means that structures are liberated step by step. So going back to the pictures, you can see that, for example, that child still has to learn how to use his leg or her legs to walk upwards. And this is done by equilibrating the structure of movement. So each higher structure is more comprehensive than its predecessor. Piaget also said that cognition is more than just collecting data. So it's not about collecting data and putting it into a database, but it's also about using reflection and construction to create new structures. So people have to reflect about the structures they are using and how they are influencing experience and cognition. For example, each individual attending the DeepSec conference will have its own point of view about the conference, because the personal biography is influencing the way how you're seeing this conference. Once you've done, or once a reflection has started, new structures can be built. And any developmental process is influenced by older structures. So the biography of any human being influences the learning process of any new task. The consequences are that epistemology will lead to at least some kind of identity. That means each IDS will be unique. So in case you are able to program an intrusion detection system that is able to really learn, it will generate some kind of own identity. So if you deploy an intrusion detection system maybe on the network of Google and another one on the network of Microsoft, and after some time, both IDS will have some kind of unique identity, and they are not comparable anymore. That means that the IDS of Google might detect an intrusion which the IDS of Microsoft might not be able to detect. So that would mean we will require some kind of asset diagnostics on IDS, because learnable IDS are no longer comparable to each other. For example, if you take a simple virus scanner, which is using just text scanning to detect a virus, you can say that a virus scanner with a lexicon or a dictionary of 1 million viruses is better than a virus scanner with a dictionary of 1,000 viruses. But this is not possible to say about an IDS that is learnable, because you cannot say or see if an IDS already has learned to detect one attack. So we would need assessment centers or asset tests to make a diagnostic if an IDS is working or not, or if an IDS might be able to detect an intrusion. Being an epistemic IDS means also that it might be able to detect new attacks, or as the psychologists say, it has the learning potential to learn the skills required to detect attacks. It does not say that it will develop these skills. Even if an IDS is able to learn, it might fail at detecting an attack or an intrusion. So now I would like to leave the Piaget universe and go back to learning. What is, or in my opinion, real learning is required to achieve proficiency in ID. With real learning, I mean a more psychological definition of learning and not a computer science definition, or the definitions currently used by computer science. One point each and every psychologist would say is true is that learning always requires a feedback loop. So one cannot learn from an unidentified attack. So it is not able to create a program or to train a human being to learn from an attack that has not been already identified. So we cannot identify, or it is not possible to automatically identify new attacks or currently unknown attacks. So we still have the diagnostical problem of predicting the future. I would like to give just a short example about that from learning theory. One of the older learning theories is so-called behaviorism. It has been influenced by Pavlov, who made the experiments with his dogs about operant conditioning. He rang a bell and gave the dogs some food, and when he then only rang the bell, the dogs started to speicheln. The dogs reacted on, they wanted their food because they're started to salivate. Yeah, they started to salivate though. Skinner, an American biologist, made some experiments with rats, cats, and dogs on so-called operant conditioning. He used rats, put them into his so-called Skinner box, and he taught them how to, or he installed several buttons in the cage, and when they pushed the right button, they got some food. And after some time, they learned which button is the right, and so they pressed on the buttons and got more food and food. And from that experiments, he created his theory of learning, which was later turned into the theory of cybernetics by Norbert Wiener. And cybernetics also influenced mechanical science and physics. But the problem is, and that's the reason why behaviorism was later dropped, they consider learning to be a simple stimulus-response mechanism. But a simple stimulus-response mechanism is very easy to be programmed. So each computer is able to react like that. Each computer program is a stimulus-response mechanism. So the mechanism is described in these 5 points. Teach the information, give the student a book, or give the computer some kind of new data, give the learner time to understand. The behaviorism does not explain how learning actually works. Then the teacher should ask a question on the subject taught to determine if the student already has understood the subject. And then you have to give, or the teacher has to give feedback based on the quality of the reaction of the student. So we still have that feedback loop. So whenever a learning process has to be started, we need some kind of feedback. And each and every intrusion detection system, or each and every human being interested in learning about attacks, has to get that feedback reaction. So there has to be already an analysis of the intrusion. So we cannot, or the human being or the computer cannot learn from a totally new attack no one knows of. So learning means we have to analyze an attack or an intrusion, and then we can try to create a didactics of intrusion and attacks, and then we can try to use it to teach those events happened. But we cannot create or develop some machine or train people to learn from events not yet analyzed. This is a model of a working ideas and training in my point of view. So my conclusion or currently working hypothesis in research are security is a social problem. Security is not only a problem of a technological dimension or a problem of computer programs or a problem of virus scanner or monitoring network traffic. In my opinion, only humans are able to detect intrusions. Only human beings have currently the skills and abilities to think about future events and to try to give a prognosis or diagnosis of an event. Computers can make no decisions, or at least no decisions of the second kind. Computers are just tools. We can use computers as a great tool to enhance security, but computers alone are not able to generate security. Security is a dimension of organizational culture. So I guess more organizational research has to be done. For example, knowledge management has been researched quite good by computer science, economy, psychology, and social science. And some of the results of knowledge management could perfectly be used on organizational security. So how should the organizational culture be influenced to stimulate people to think about computer security, think about security awareness or such. Security awareness is only working when the organizational culture is supporting awareness, and it's supporting learning by the individual and organizational learning. And we currently have no theory of organizational security. I would like to create, or at least try to develop such kind of theory where security is viewed from the organizational point of view, from a more upper level than just a technological view. I would like to leave the level where only TCP/IP packets are analyzed or some cryptographic signatures are viewed. And I would like to also include human beings, human behavior, human actions, philosophy, and of course, more or less a theory of organizational structures. So once again, from my current experience as someone who is conducting security awareness campaigns, those structures or structures established within an organization give the possibilities to create an organizational culture which is security aware, but the structure alone does not create security awareness. It just gives the possibility for the human beings to become security aware. So, okay, faster than thought. Questions, discussions, or was it too esoteric for you, or too philosophical? Or? Yes? Okay. Traffic anomaly. From
is it coming close to what you're talking about?
Yes, maybe on another level. So I guess anomaly detection already also has a diagnostical problem. So if you already know what kind of anomaly is an intrusion, you can perfectly write a computer program that works it. But if you do not know which anomaly will lead to an attack or is an attack, you cannot analyze it and you cannot react on it or prevent it. So these philosophical questions I rose are applying to any kind of intrusion detection. And what I try to set is that some levels can perfectly be worked by computers. For example, traffic anomaly, that's the perfect work for computer. But on the organizational point or from a higher level, you also have to include human beings.
Any more questions?
Many of the questions you raised in this presentation were, I think, in the late 1980s or early 1990s, have been reported regarding these expert systems, decision-making systems. Yes. And where do you defer those systems? Because I think the research on that fell kind of asleep in the last years. I haven't heard a lot about that. Where do you differentiate those from IDS systems?
That's an interesting question. I'm doing some studying on knowledge management, and we also have these topics there too. When we have a lecture at university, we usually have psychologists, computer scientists, and economists in these lectures, and they are also the same discussions about that. So I think from a technical point of view, they might work on several problems, but what I have to say, they are also just tools, and they have to be used by some kind of organization, some kind of strategy and human beings. So a lot of these points that have to be discussed here by organizational security research have already been discussed in knowledge management, decision making, and such. And like with traffic anomaly detection, it works on some problems, but it works on others not. And there is also the run between how Clausewitz said in his book on war. There is always a run between the sword and the shield. So once you develop a strategy to defend something, an attacker will create a strategy to attack it. There was an example. I read a book about the Israeli El Al airline. They used trained psychologists at the airports to look out for potential terrorists. So they stand there and they had some kind of checklist who might be a potential Palestinian or Arabian terrorist. And they looked, for example, to those Palestinian or Arabians who had beards because they are forced by their Quran to have a beard. And once the Palestinian terror organizations realized that they were looking for men with beard, they tried, the terrorists shaved and wore a business suit. And so the LR fixed the checklist and said, okay, also look out for business suits and shaved Palestinians. And once the Palestinians realized that, they used women because the Israeli defense forces in El Al didn't expect women to carry bombs. And so they had some kind of run, and that from a strategic point of view will also happen to any kind of defense technology. Okay. So anyone interested in developing a strategy on defense should read Clausewitz on War. It has been written in the 18th century by a German colonel, and it's giving a lot of still working hints on developing a strategy.
Do we have any further questions? No. Okay.
So if you're interested, if you have further questions or suggestions, feel free to contact me. I also have business cards here. I'm, like I said, interested in doing more research on that. So maybe we could get in contact. Okay. Thanks.